हेलो स्टूडेंट्स। हमने डिफरेंशियल कैलकुलस के पिछले लेक्चर में हमने फंक्शन की लिमिट डिफाइन की। फिर हमने उसकी लिमिट के एक्सचेंज के बारे में बात की कि एक लिमिट एग्जिस्ट दैट इज यूनिक। फिर हमने कहा कि अगर किसी फंक्शन की किसी पॉइंट के नेबरहुड में लिमिट एग्जिस्ट करती है तो उस फंक्शन के उस पॉइंट के नेबरहुड में फंक्शन बाउंडेड होगा, और उस पर बेस्ड हमने डेफिनेशन से क्वेश्चन सॉल्व किए। अब हम इस प्रोसेस को आगे बढ़ाते हैं, अलजेब्रा ऑफ लिमिट डिस्कस करते हैं। हमने जब भी नई चीज नया कॉन्सेप्ट डिफाइन किया है फंक्शन, और इसकी लिमिट हमने डिफाइन की है, तो इस पे हम देखेंगे अलजेब्रा में जो चार ऑपरेशन होते हैं, एडिशन, सब्ट्रैक्शन, मल्टीप्लिकेशन, डिवीजन। अगर किन्हीं दो फंक्शन की लिमिट एग्जिस्ट करती है तो उसके सम की लिमिट क्या होगी, उसके डिफरेंस की क्या होगी, उसके कोशेंट की क्या होगी, उसके प्रोडक्ट की क्या होगी। और अगर किसी फंक्शन लिमिट एग्जिस्ट करती है, उसको किसी स्केलर से मल्टीप्लाई करें तो उसकी लिमिट को क्या इफेक्ट होगा, ये हम इसमें स्टडी करेंगे, इस लेक्चर में स्टडी करेंगे। तो पहली थ्योरम स्टार्ट करते हैं। लेट एफ एक्स बी ए रियल वैल्यूड फंक्शन सच दैट लिमिट एक्स अप्रोचेस टू ए ऑफ एफ एक्स इज एल, देन limit x to a of k into fx is equal to k into l, where k is a real number of k is a scalar. Proof given is proof of this is given is limit x approaches to a of fx is l. Definition of limit. This implies we have, if limit exists in the neighborhood of a given epsilon greater than 0, how small? We'll fix the value of this. How small? There exists a positive number delta depending upon epsilon such that modulus of fx minus L is less than epsilon for all 0 less than x minus A less than delta. This is, which neighborhood is this of A? This is the delta deleted neighborhood of A. Now this is given. Now what to prove? We have to prove that limit x is to a of k into fx is equal to k into L. That is what to prove. That is given. It can be epsilon or it can be epsilon dash. I'll let you know in the conclusion of the theorem. Epsilon dash greater than 0. How small? There is positive number delta depending upon epsilon, such that modulus, if this exists, then this inequality holds true within epsilon, and we have a delta epsilon. Modulus of k into fx minus k into L is less than epsilon dash for all 0 less than equal to x minus less than delta. So we have taken the left hand side of this. What we have to prove? So this is equal to left hand side. This is k into fx minus kl is equal to k is common. Is modulus of k into fx minus L. Modulus of product is equal to product of the modulus, then modulus of k, and this real number fx minus L. Now fx minus L is definition. The limit of function fx exists at the neighborhood point A. Therefore, substituting the value from equation using equation 1, we will get, we have replaced it by the greater number. This is a real number. We have substituted this by the greater number epsilon. So relation become less than k into epsilon for all 0 less than x minus a less than delta. So if k, now this epsilon is a very small number, and k is any fixed scalar or real number. If you multiply a very small number by a fixed finite number, very small number will remain very small. So we can write here. We can write here also. If we can write here epsilon dash, or epsilon dash is less than 0 less than x minus less than delta, or we can write in this is given here. We can write upon k here. If this is very small number divided by k finite number, very small number will be very small, and substitute the value of here, the k will be cancelled out and we'll get epsilon here. So both ways we can prove it both ways. Means epsilon dash is also equivalent to epsilon, or epsilon is equal to epsilon, because if very small number is multiplied or divided by a finite number, very small number will remain very small. So this now k into fx minus kl is less than epsilon in the delta derivative of a, implies limit x is to x approaches to a of k into fx is equal to l is equal. Now next change. Let fx and gx be two real valued functions such that limit x approaches to a of fxl and limit x approaches to a of gx equal to m. Then we'll prove that limit x approaches to a of fx plus gx is equal to l plus m, and limit x is to a of fx minus l and gx is less than equal to is equal to l minus m. Third is limit x approaches to a of fx into gx is equal to l into n, and limit x which is to of fx upon gx is equal to l upon m, provided your n is not equal to 0. Now proof for first part. First part is so, we are given that given limit x is to a of fxl and limit x approaches to a of gx equal to m. Now the definition of limit, given epsilon greater than 0, how small there exists there is positive real number delta 1 depending on the epsilon and delta 2 epsilon such that fx1 fx minus l modulus less than epsilon 2 for all 0 less than x minus a less than delta 1. Similarly, limit x to a of gx equal to m implies given x greater than 0 there is possibility of delta 2 epsilon such that fx gx minus m is less than epsilon by 2 for all 0 less than x minus a less than delta. Now this y in place of epsilon 0 to epsilon by 2 and plus epsilon 0 to epsilon 2, again the same logic. Epsilon is very small number. Epsilon is how small? Very small number means epsilon given epsilon how small means very small number. Very small number divided by fine number. This number will be very small. So and similar the case here. Now we will see the both inequalities being true in the same interval. So this is true in this diagram shows a minus delta 2 plus delta excluding a, and the second inequality holds true a minus delta 2 a plus delta 2 excluding a. So now we'll let us suppose delta 2 is minimum. This means we are supposing that both inequality, this inequality and this holds true in the common neighborhood of a. So in this case delta is equal to how much? Delta 1 means a minus delta 1 to a plus delta, both these inequalities hold true. So now this first and second we give us this is equal to 2 in the same way. Delta is delta in this case. Now first result is now we'll put that what to prove? We have to prove that limit x which is to a of fx plus gx is equal to l plus m. That is what to prove. Again the definition. Given epsilon greater than 0 how small there is a positive number delta such that fx plus gx minus l plus m modulus less than epsilon for all 0 less than x minus a less than delta. So we have taken the left hand side of the using definition. This is equal to now arranging the terms for the use of third and fourth fx minus l and gx minus m less than m. Now these are real numbers. These are real numbers. Using 3 and 4, modulus of sum is less than equal to modulus a plus b and modulus a plus modulus b. So using here modulus a plus b is less than modulus a plus b and modulus fx minus l plus modulus b. Now substituting the values, this is less than epsilon 2 into delta denoted of a gx minus m is less than epsilon 2 into delta denoted of a. So both inequalities substituting here, this is true in which delta denoted of a. So adding them, this is the epsilon. So fx, now fx is a new function and l plus m new number. So after adding the two functions whose limit exists, they will converge to the limit of sum. So that's epsilon implies, definition implies if the limit of a function exists and they have certain values, then the limit of the sum is equal to sum of the values. Similarly, you can prove for the difference. If the limit of two functions exists and they have certain values, then the limit of the difference is difference of the limits. You prove it yourself. Now next part is prove. Next part, third part will prove that Prove that limit x is to a of fx into gx is equal to L into M. L to M. What to prove? That is, given epsilon dash, how small, there is position of delta, to express such that definition again. You want to prove this means you have to prove this thing or this thing or so modulus of fx into gx minus lm is less than epsilon for all delta divided in the root of a. So we are taking again left hand side, this left hand side. So we have added in order to convert using the second result, this third and fourth result. Here we have added mfx, and separate mfx, and that. Or you can do it by adding lgx, separating lgx and lgx. Both we can do this. So for I'm adding separating mgx, mfx, and adding mf. Both cancel. You get the same result. Left hand side you get the same thing. So now rearrange the term for the use of third and fourth result. Now rearrange the term and take common factors. So this fx is common, L is common, is equal to gx minus m. Now m is common, is equal to fx minus L. So modulus of sum is less than equal to modulus of sum less than equal to, and modulus of product is equal to product. These result is the tool for, because we are dealing, they are real numbers, so they are all real numbers. We are using the results so complex because every real number is a complex number. The complex chapter plus one, we have put what we have read, we are using those results. ठीक है, उन रिजल्ट को यूज कर रहे हैं यहाँ पे. अब क्या हमारे पास आया, ये मेरे पास आ गया. अब क्या हुआ, ये इसकी वैल्यू पता है हमें किस नेबरहुड में, डेल्टा नेबरहुड में. इसकी वैल्यू पता है, ये फिक्स नंबर है. नाउ इसकी वैल्यू पता नहीं है, तो हमने क्या इसमें कॉन्सेप्ट यूज किया कि इसको इसकी मैक्सिमम वैल्यू निकाली हमने. इसको कहते हैं कि किसी छोटा उसको बड़ा कर रहे हैं हम, जैसे ये चीज़ क्या, इससे इससे ये चीज़ से छोटी होगी. अब राइट हैंड को और बड़ा करेंगे, तो बड़े नंबर से छोटे से निकालेंगे. Now using theorem, limit x approaches to a of x is n, then fx is bounded in a dating node. If limit of function at a point exists, then the function is bounded in that node. So now test. If it is bounded, if fx is bounded in dating node of a, delta dating node of a, therefore there exists a positive number k such that modulus of fx is less than k for all x belongs to for all x belongs to x minus in neighborhood of a. X minus means this is x minus a less than delta dash. Now this result, these two results are true in a neighborhood delta neighborhood of a. Now we suppose this is bounded. This is bounded in a delta dash neighborhood of a. Now combining third, fourth, and fifth. For combination for the third, fourth, and fifth they have common domain. Let us choose delta double dash to be minimum of this. Notice this again. We are taking a common domain in which both fx minus L and gx minus m is less than epsilon, both epsilon less than root 2, and modulus of fx is less than k in the common domain. For to make a common domain, we are choosing delta to be minimum. If delta 1 is minimum, delta dash will be delta. If delta dash is minimum, is less than delta, then delta double dash will be delta dash. Now third, fourth, and fifth way, using the third, fourth, and fifth way. The fifth implies given epsilon dash greater than 0, however small, there is positive number delta dash double dash greater than 0, such that third, fourth, fifth gives us that in the delta dash double dash greater than the root of a, third, fourth, and fifth. This means fx minus L is less than equal to x minus L is less than equal to, and fx is less than modulus L is less than k for all 0 less than x minus L less than delta. So this delta double dash greater than the root of a, these three inequations hold true. Now using sixth and fifth, value of f is is a positive real. So after substituting the value, this is equal to k into k. Modulus f is less than k. You make them greater. Right? So बड़ा क्या हमने section 2 again fx minus l less than epsilon. So replace fx minus l by fx minus l by so gx minus l gx minus by gx minus m by epsilon 2 greater number. Modulus m is the same and fx minus l by greater number epsilon 2. Substituting their values and now this is very small number. Epsilon is very small number. If you multiply it with very small number, k by 2, very small number. Now similarly here, m by 2 is a fixed number. Epsilon is a very small number. How small we can take? Multiply a very small number by any finite number, very small number. So sum of two very small numbers, they are very small. Therefore, this is epsilon. This is very small number. This is very close to 0. This is equal to 0. So fx into gx minus lm is less than epsilon dash. So for all g plus x minus a less than delta dash implies definition implies limit of product is the product of the limits. If the limit of two functions exist, then the product of the limit is equal to exist and there are certain finite numbers, then the limit of product of two functions is equal to product of the limits. So we can do these also. Now next is the limit of what about the limit if the limit of two functions exists, what about the limit of the quotient provided your limit of denominator is not equal to. Now given is limit x is to a of fx is l, limit x is to a of gx is equal to m. What to prove? Limit of x is to a, x approaches to a of fx upon gx is equal to n into l by m, provided your m is not equal to 0. Now what to prove? To prove is given epsilon greater than 0, how small there is positive limit delta given epsilon such that modulus of fx minus l gx is minus 1 upon m of l upon m is modulus of epsilon for all in a delta denominator. Okay. Now again we took the left hand side, simplified it. Left hand side this LCM modulus this, simplified it, LCM multiplied them, then again is equal to modulus product is modulus quotient is modulus. Now again the numerator, if you want to use the result third and fourth, you want to use the results this the third and fourth of previous theorem. We added here lm subtract lm added a numerator, so means they cancel out, numerator remains the same, and this is equal to upon gx modulus of now now this is equal to this, now this is equal to sum of two functions. We are converting them into the result of modulus of fx minus l gx minus m. This is equal to modulus of product is less than equal to modulus of product, and modulus of product is product of modulus. This will become less, using this will become less than equal to modulus m modulus fx minus l plus modulus l modulus of gx minus m upon modulus m into modulus of. Now again there, now we'll fix the value. Now fx upon gx minus l upon n modulus is less than this. Now this is a fixed number. Now denominator this gx varies, take different value in the okay. Now we'll decide the value when substitute separating them. That is after separation because this under this and this and separate parts no, then we go to part this and this. We know this is less than epsilon 2. We know this is less than epsilon 2. The denominator of a. Now we are left with what will the value of g? For this value of g, we have to fix epsilon. So now we are given that. Now we have to find the value because if you want to इस inequality को बरकरार रखने के हम राइट हैंड साइड को क्या करेंगे, बड़ा करेंगे. बड़ा करने में मतलब क्या होगा, डिनोमिनेटर को छोटा करना पड़ेगा. छोटा करने के लिए हम गिवन एप्सिलॉन जो हमारा था उसकी हेल्प लेंगे. उसमें अब क्या था, gx की लिमिट x अपोजिट टू f gx m थी तो हमारे पास क्या था, Limit x की होती थी gives us that gx is bounded negatively of it, and we will find its lower bound. लोअर बाउंड में इसको जब हम इसको स्मॉल करेंगे तो डेल्टा बड़ा होगा, अगर इसको बड़ा इसको बड़ी बड़ी इसको करेंगे तो बड़ा इनक्वलिटी रिवर्स हो जाएगी. सो कैलकुलस में जब जब इनक्वलिटी के लेफ्ट साइड की टर्म को कर छोटा करेंगे और राइट साइड टर्म को बड़ा करेंगे. बड़ा करने के लिए न्यूटन को छोटा करना मीन्स इसके ग्रेटेस्ट लोअर बाउंड से रिप्लेस करेंगे इसको. उसी के लिए हम इसको एप्सिलॉन चूज करेंगे डेफिनेशन में. अब एप्सिलॉन को हमने चूज किया, फिक्स वैल्यू किया, हमने यहाँ नहीं बोला, फिक्स वैल्यू देखिए हमने यहाँ पे. ठीक है, एम क्या दी लिमिट थी उसके मॉडल्स पर 2 देखिए, लिमिट इसके मॉडल्स पर 2 ग्रेटर देन एप्सिलॉन एफ ग्रेटर देन 0 भी है. हाउ स्मॉल इट्स स्मॉल ले सकते थे हम इसको, हमने फिक्स कर दिया इस केस के लिए दोनों इसको सेट करना है. ठीक है, अब चॉइस नंबर था ये हो चॉइस नंबर. अभी हमारा हर बार में इसको ऑप्शन पे अच्छे से देखा है हमारा और इसको क्लियर करना है. we find we can find delta 1 dependent option such that fx minus m modulus is less than epsilon for all zero in delta 1 dependent. ठीक है, अब बिकॉज लिमिट फिक्स करी थी एप्सिलॉन फिक्स कर दिया तो उसकी वैल्यू क्या है मॉडुलस एम. अब हमने क्या, हमने लोअर बाउंड निकालने के लिए हमने एक स्टेप में याद रखना पड़ेगा. तो हमने मॉडुलस एम यहाँ पे सेट किया, मॉडुलस एम इसमें कर दिया हमने माइनस जी एक्स प्लस जी एक्स कर दिया. अब जी एक्स निकालने के लिए हमने जी एक्स किस चीज़ बड़ा छोटा है तो हमने जी एक्स किया. इसमें से क्या लिया माइनस कॉमन ले लिया, माइनस कॉमन लिया, जैसे मॉडुलस होते हैं मॉडुलस ऑफ माइनस इसको किसमें कट किया जी एक्स माइनस एम. तो हमें पता है जिससे एप्सिलॉन टू छोटा है एम बाई मॉडुलस एम टू छोटा है, पता है इसलिए इसको मॉडुलस सम ऑफ द मॉडुलस माइनस है मॉडुलस माइनस ऑफ एक्स इक्वल टू मॉडुलस एक्स जो दो हम मॉडुलस. अब इसकी वजह से कर दिया हमने किसे इसको और बड़ा किया, किसे बड़ा रिप्लेस किया तो मॉडुलस एम किया, मॉडुलस एम बाई 2 से रिप्लेस कर दिया. अब इक्वलिटी कब 2 है ये इसे डेल्टा 1 डिवाइडेड बाय 2. ठीक है, यह है हमने इसको लिया और इससे हम फॉर्मूला को दिया वो हमारा. अब इससे हमने जीएक्स का लोअर बाउंड निकाला. ये था इससे बड़ा था इसको राइट में चले दोनों तरफ ऐड कर देंगे सेपरेटिंग और से बटू बोथ साइड्स. ये कैंसिल शिफ्ट होगा इससे शिफ्ट हो सिंपलीफाई कर दिया इक्वल टू नाउ इन द डेल्टा 1 रिलेटेड रूट ऑफ ए 1 m modulus m by 2 will be less than gx in the delta 1 रिलेटेड रूट. अब इसकी वैल्यू क्या, अब दोनों की लिमिट क्या थी, अब यहाँ दोनों लिमिट पिछले जो लिमिट क्या हमने इसकी लिमिट इसकी कर दी, एक हमने लगाई थी ना इसकी डेफिनेशन. अब इसको हमने इसको अब दोनों लिमिट्स के गिवन एप्सिलॉन डेल्टा 2 एंड डेल्टा 3 सच दैट ग्रेटर 0 सच दैट इसे कैलकुलेशन एफएक्ट मानेगा सब्स्टिट्यूट 2 कुछ भी स्टेप बाय 2 के प्रूफ मल्टीप्लिकेशन में और डेल्टा 2 रीजनल ग्रुप gx minus m is less than epsilon 2 for all delta 3 रीजनल ग्रुप. नाउ अब इसको हमने इसको यूज करना है यहाँ पे इसको इनको इसको इसको इसमें प्लेस करना है इसमें इसमें वन में प्लेस सब्स्टिट्यूट करनी है इसकी इसकी एफ एक्स माइनस एल मॉडल की जी एक्स माइनस एल मॉडल की और जी एक्स की सब्स्टिट्यूट करनी है. तो हमने तीनों का कॉमन डोमेन किया इसको. तो ये 2 था क्या था ये जी एक्स माइनस एम था. जी एक्स माइनस एम किससे बड़ा हमारा एम बाई 2 से. जी एक्स मॉडुलस किससे बड़ा था और एम बाई 2 से कब था ये डेल्टा 1 रिलेटेड. और ये दोनों कब थे दोनों इंडेक्स से दोनों कब थे एफ एक्स माइनस एल लेस देन 2 कब था डेल्टा 2 रिलेटेड ग्रुप है. जी एक्स माइनस एम कब 2 था जिससे 2 कब था ये जिससे डेल्टा 2 रिलेटेड ग्रुप है. तो अब तीनों को कंबाइन कर दिया तीनों रिजल्ट है तीनों इनक्वलिटीज कब 2 है. हमने डेल्टा के लिए कॉमन डोमेन ले लिया हमने कॉमन डोमेन के लिए दैट्स व्हेन चूज मिनिमम. जो तीनों छोटा होगा वो होगा डेल्टा डेल्टा. फर्स्ट है इक्वलिटी थर्ड फोर्थ एंड फिफ्थ होल्स इन दिस. ठीक है, डेल्टा नोट में आ गया यूजिंग 3 रिजल्ट यूजिंग 3 इन रिजल्ट 4 थर्ड इसको रिजल्ट 4 रिजल्ट 1 भी चूज किया यूजिंग 3 4 equal to 3 4 in this interval. So using 3 or 7. Using 3 4 to 6 using 3 4 and 5 in फर्स्ट ये निकाल दिया, इसकी सब्स्टिट्यूट वैल्यू, इसकी यूनिट को छोटा किया तो बड़ा हो गया, ये ऐसा हो गया, इक्वल टू था वहाँ, ये क्या था यहाँ पे, दिस वाज इक्वल टू, जब हमने इसको यूनिट को छोटा कर दिया तो बड़ा हो गया, ये एक ही नंबर से बड़ा करने से बड़ा हो गया, ये दिस इज इक्वल टू क्या हो गया, ये दिस इज ग्रेटर देन एम बाई टू, इस ग्रेटर देन यूनिट छोटा किया तो बड़ा हो गया। अब ये एक छोटा है एप्सिलॉन एप्सिलॉन टू से, छोटा है एप्सिलॉन टू से, दोनों को सब्स्टिट्यूट कर दिया हमने, दिस इक्वल टू एप्सिलॉन टू एप्सिलॉन टू। अब क्या हुई है, टू कैंसल, this is epsilon by modulus m, this is 2 cancel, this is modulus m by modulus l upon modulus m square. Now this is very small number multiply finite number, very small number multiply finite number, so divided by finite number, both very small number divided plus very small number, very small. Now when this is true, this is true for all the delta neighborhood of A, implies definition x is to A of fx upon gx is equal to L minus is equal to L minus. Thank you.